Alright guys, so this video is on how do we use all of our equations to solve problems. What do problems look like in this course? And you've already seen a bunch of them. So we're talking a little bit about problem solving strategies. Last time we talked about these three equations. They're kind of scary, and where do they come from? And we're going to look at all of them. How can we use them all for problems? And I have a little method that I've been taught that I think is more effective in the sense that you have a greater likelihood of getting a problem right if you follow this method. And I think it works. And it'll kind of morph and change as the year goes on, but this is how I like to start things. So here's a problem. The problem in physics is that we do what are called word problems, and word problems have words in them. They also have numbers. Word problems are tough because you have to read, you have to interpret what's going on. You have to have a mental picture in your head. And so a lot of students, when they're confronted with these, it's a challenge because a lot of people have trouble with reading comprehension. Some people read, and I've watched students do it for years, where they'll read the words on the page and not understand what's going on. The nice thing about physics is that it's grounded in the real world. So you're going to bring your own real world experiences with you when you do problems. So a problem like this, you've got a car. Looks like it's starting from rest, so maybe it's at a red light. It starts from rest with a constant acceleration of, and they give you some numbers and some units. If it accelerates and it's a positive number, I guess that means it speeds up and it's along a straight line. Okay. So, how do we go about solving this problem? And there's a bunch of stuff that's going to happen. Look at all that stuff. So we're going to go through that. So here's my problem solving strategy that I like to follow. I think you should write this down. I think this is something that you should do. My problem is that a lot of students won't do this. They have too much to do. They couldn't be bothered. They're too busy. They want instantaneous results. They want things to happen now. And so if people have trouble, partly it's due to the fact that they won't follow this process. Okay, so let me get this going again. So these are the steps that I think you should go through. Step 1, relax. This is actually the hardest step for me. I'm a very anxious guy. I'm worried about everything. I'm worried about not knowing whatever answer to whatever question people ask me. And so step 1 is hard for me. Relax. You need to be relaxed. This also is just a good overall advice for how you should study for all of your classes. You need a quiet space. It needs to be clean and organized. And it's really hard to focus on anything if there's a lot of chaos, a lot of mess. So you need to find a nice, clean, quiet place. And be relaxed. Breathe. The next step in the problem-solving strategy is to read. Read the problem. You'd be amazed at the number of folks who won't do this. They want to get right to it, and they just start plugging in numbers. Read the problem. There is what we call context in every problem. What's going on within that problem? Okay. First you relax, then you read the problem. You may have to read it twice. I usually have to read them several times. Try to come up with a mental picture. Then I draw a picture of something, anything. I try to draw some type of picture about what's going on. Okay. So far, those are my 3 steps. Okay. We'll come back to that next part. So here's our problem again. Right. I'm relaxed. I breathe. I have my coffee. I'm doing good. I have some idea of what's going on here because we have a car. Okay. So let me go. I'll address this here in a second. So if I have my car, I'm just going to, the car is driving on a flat road. Try to draw a car. I can't draw a car. What is that? I don't know. But that's my car. My car is going to go that way. I guess. It's going to speed up. What did that problem say? Car starts from rest. Well, look at all this crap. We'll talk about all that here in a minute. It starts from rest. So that means my initial velocity, it starts from rest, is 0. Okay. So sometimes when you read these problems, some of these stuff will be in words, and you can actually take those words and turn it into numbers, right? At rest means it starts at 0. It has a constant acceleration, so it's going to speed up. I need to know what this word means. These units, looking at those, that would be helpful to know what that is. Along a straight line, find the speed at the end of 5 seconds. So it looks like we have a time of 5 seconds. This is meters per second, right? And so what's my final speed? What's my VF? So I'll try to come up with a crappy, quick picture. You know, there's my car. If you're bad about drawing, just like me, obviously draw a dot to represent the car. Now, what I do next, I've relaxed, I've read the problem, drawn something. A lot of people like to underline things within the problem itself. So they will highlight things from rest. It means it starts at 0 speed. An acceleration of, okay? You need to know where you're going, so you need to know what you're trying to solve for. Find the speed at the end of 5 seconds. So that tells me that after a certain time has gone by, what's the speed? Now, the next thing I do is I build a chart. And this is what my chart always looks like. For kinematics problems, I like to build a chart. Initial displacement, final displacement, initial velocity, final velocity, acceleration, and time. Those are all the different variables that we have. Look, if you look at this whole page here, those are the only things. Velocities, times, displacements, acceleration. That's all that's there. We're doing kinematics problems. Okay? That's it. If you look at each one of these, that's all that's in there. So I build a chart. Okay? So for this car problem, my initial velocity looks like it's 0 meters per second. My final velocity, I don't know. I'm going to put a question mark. That's so important. If you don't know where you're going in any problem, you're not going to get there. So I put a question mark. I think it said our A was 8 meters per second squared. So A is 8 meters per second squared. It's 8. The time they told us, this all takes place in 5 seconds. So I'll try to populate this chart. Do I know displacements? Let me look at the problem again. A car starts. It doesn't say anything about displacement, so I can leave these blank. Maybe I'm going to find them later. I don't know. So now I've done my best to fill out this chart with stuff I know and stuff I'm trying to find. Okay. It looks like I know, or I'm trying to find 4 things of the 6 in the chart. So what I do next, this is my next problem-solving step, after building the chart, is I choose an equation. Which equation are we going to use? So what I do is I look at my list, and I try to decide which equation will work. I got VI, VF, A, and T. Which equation? And there might be more than one. So I choose the one that's the easiest. Which one has initial speed, final speed, A, and T? Initial speed, final speed, A, and T. Looks like equation number 1 is the best one to use. So that's what I'm going to do. That's the one I'm going to use. And then I'll write it down. I actually write the equation down that I'm going to use. And then I plug things in. Question mark equals 0 plus my A is 8, my time is 5. And I solve it. 0 plus, what's 8 times 5? Okay. So if you look at this process, it looks like, look at that, it's the exact same thing. So I built my chart here. Initial displacement, final, initial speed, final speed, A and T. I put everything in there. Looks like we're assuming that the initial displacement is 0, so it's just at some starting point. I chose my equation. Here's my answer. Okay, there you go. So this is the problem-solving steps that I use to do problems. Part B here says find the average speed of the car for that 5 seconds. Here again, you have to read in between the lines. They want average. The word average shows up. This was instantaneous. In other words, at 5 seconds, how fast is that car going? That's right then. That's like if you're a cop and you are radaring someone on the side of the road at 5 seconds. Boom. So this is an instantaneous thing, which is why we used equation number 1. This is average speed. To find any sort of average, how do you do that? You just add everything up and divide by how many there are. So if we had an initial speed and we had a final speed, our initial speed was 0, our final speed was 40. We had 2 different speeds, initial and final, and then you add them up and divide by how many there are. 40 over 2 is 20. So that is a nice little problem. Okay, so we can do a few more here before time runs out. Here we go. Here's one. Relax. Read. Can you draw a picture? This is talking about a thing called a train. Hopefully everyone knows what a train is. It looks like the speed of the train is reduced, so it slows down from 15 to 7. It travels a displacement or a distance of 90. What I do first is I build my chart. What do I know here? I know an initial velocity. I know a final. I know a displacement. These units, those are your clues. You need to know what all these units are. What are we trying to find? We're trying to find A. I build a chart. I know my initial and final displacements. We'll say it starts at 0 when the time starts and it ends at 90. Our initial speed is 15, final speed is 7. We're looking for A. We don't know a time, so I don't have anything to put in where that T is. Then you choose one of your 3 equations. Which one can we choose? It needs to have an A in it. It's the one equation that has A but doesn't have time. There is one that doesn't have time. It's equation number 3. Equation number 3 is one that is overlooked. Doesn't have time in it. A lot of people will solve for time first. That you can, but that just takes more time. I just use the one that doesn't have time in it and solve it. Oops, so I rearrange stuff. And this is the math part. The physics is done right here, right? You read it, draw a picture, which I didn't put a cute little picture. Make a chart. Choose your equation. That's where all the physics is done. And then do math. Negative answers are okay for accelerations. What does that mean, guys? What did the train do? Slowed down. Ooh, here's one. Can you do it? Looks like they used the same equation and just solved for displacement.